Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 9 of electronics guys. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details to your friends as well so that they will also be benefited from it. Okay guys, so let's get started. So electronics. So I'm going to discuss admittance and H parameters today. Okay. So admittance. Okay, that is Y parameter. Okay. So Y parameter. Y parameters. Y parameters. Okay. Or this is called admittance. 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 Okay. Y parameter or admittance. Okay. Y parameter or admittance. Okay. So Y parameter is that this Y parameter is equal to, so Z parameter is 1 upon Y. So Y parameter is inversely proportional to impedance. Okay, so admittance is uh, inversely proportional to impedance, or Y equal to 1 upon Z. This we need to note down. Okay, so Z is impedance. Z parameter I have already explained in my previous lecture, impedance. So I'm explaining admittance today, and and the relation between impedance and admittance is impedance is or admittance is inversely proportional to impedance. Okay, so Y equal to 1 upon Z, or Z equal to 1 upon Y. Okay, so here also I told you that you need to note down this R4. Okay, I means this input, reverse, F is forward, and this is output. Okay, so now we know here I1 is function of V1 and V2 in this case, and I2 is function of FV1 and V2. Okay, and I1 is equal to Y1, this is YI guys, input. Okay, Y input, YI V1 plus YR V2, and I2 equal to YF V1 plus Y0 V2. Okay, Y0 means this output. Okay, this is about the Y parameter. Now I'll find parameters one by one. So here yi is input. Y input is I1 upon V1. I1 upon V1. Okay, at V2 equal to 0. Y1 upon V1. Okay, and YR is reverse. I1 upon V2. Okay, at V1 equal to 0. Third is YF, Y forward. Okay, these are the parameters, Y parameters. Okay, YF is I2 upon V1, I2 upon V1 at V2 equal to 0, and Y output is I2 upon V2, I2 upon V2, I2 upon V2 at V1 equal to 0. So these are the Y parameters, guys, very important. Meanwhile, just let me check whether I'm audible or not, then I'll proceed further. I2 upon V2, yes, I'm audible, so I'll proceed further. Okay, so these are values of, these are y parameters, guys. Very important. Okay. Okay, now I will solve one question, then it's going to clear your all doubt, okay, regarding y parameter. Okay, so question is this one, guys. This one, and this is V1. Okay, this is V2. Okay, and the resistance is, this is 1, this is 1, and this is 2 ohm, ohm, ohm. Okay, these are the resistances, and this is the figure. Okay, so now you need to find out y parameters. This is y of I, yr, yfo, right? IRFO. IRFO, you need, this word you need to find, note down, IRFO. Okay, so let's start. Let's get started. So now in this loop we'll find I1. Okay, I1. In this loop is I1 is going to be, because I1 equal to this one, uh, this I1 upon V1, V2 equal to 0. Okay, so here this I1 value, if you want to find, so this is going to be I1 value. Okay, just I1 here. This is I1, guys, and this is I2. Okay, I1, this is I2. So I1 is going to be this one, V1 upon, just we are going to, because V2 is 0, right? Because why we are going, so because we know we are finding Y1, right? Yi. So at this point V2 equal to 0. So V2 is 0, so I1 current we are going to find. So I1 is going to be this voltage upon resistor, right? So these two resistors are in parallel and this is in series. So this is 2 plus, this in series means 2 into 1 upon 2 plus 1. This is very important because V2 is 0. Okay, because for yi we are going to find V2 equal to 0. V2 equal to 0 means we will find I1, current I1. Okay, so their V2 is 0. So here the because these three resistances are in this is in these are in parallel and this is in series, right? So this will be V1 upon this one, and this value is going to be uh, V1 upon 5 by 2. Okay, if we solve it, and this is going to be 3V1 upon 5. This is the value of I1, guys. Now we can find out yi, the first parameter. This is a formula we know, I1 upon I2, I1 upon V1, V2 equal to 0, right? And V2 equal to 0, I1 upon V1. I1 upon V1 means I1 is 3V1 upon 5 upon V1. V1 will get cancelled. So this value is going to be 3 by 5. Okay, 3 by 5. Okay, so this is the value, or this is ohm inverse, or Siemens is the unit for it. Okay, or we write MHO also. We write MHO. Okay, ohm inverse. Okay, so this is the yi, first parameter we have to find. Second parameter, for second parameter yr, we know yr equal to I1 upon V2 at V1 equal to 0. At V1 equal to 0. Okay, so this is going to be, guys, so we need I1, right? So I1 we are going to find, I1 will find in terms of V2, so that V2 will get cancelled. Okay, I1. So here you need to understand I1. So here we are going to use current divider rule. Okay, so this is I1, and so we know how to use it. This is I1. Suppose so this is I2, right? So first we will use current divider rule here. I2 current is coming and then it is getting divided into 2 in this part, right? This is I1 and this is I1 minus I2 minus I1, right? So I1. So this part of current, if you have to find that I have already explained current divider rule. So this is I1 is going to be I2 into 2 this resistance upon this resistance plus this resistance, right? So this is I1 is going to be I2 into this resistance, different resistance, right? This resistance upon this resistance plus this resistance upon 1 plus 2. So this I1 value is going to be 2I2. This is important one, okay? Current divider rule we have. So 2I2 upon 3. Okay, this one. So now YR is I1 upon V2, right? So I2 upon 3. Now we'll find I2 value again. We'll find I2 value here. The same thing. I2 value, we have to find I2 value. Okay, at V equal to 0, right? I2 value. I2 value means this volt upon this resistance, right? This resistance, these are in parallel and series with this, right? As similar as we have found this one. So I2 is going to be V2 in this loop. Okay, V2 upon this the effect the R equivalent for these three, right? These two are in parallel and this is in series, right? So this is going to be V2 upon 1 plus. So this is going to be V2 upon 1 plus 2 into 1 upon 2 plus 1, right? So we'll solve it. So this is going to be 3V2 upon 5. Okay, 3V2 upon 5. Now, so therefore I1 value is going to be I1 value. We'll put the value of I2. So 2 into 2 by 3 into this 3V2 upon 5. 3 will get cancelled. So this is 2V2 upon 5. This is I1. 2V2 upon 5. So we have got I2, I1 in terms of V2. So now YR is YR is going to be value of YR. YR is going to be this one. I1 upon V2 or I1 value we have already found. This is 2V2 upon 5. 2V2 upon 5 upon V2. This will get cancelled. 2 by 5 MHO, Siemens or ohm inverse, right? MHO, right? And now we'll find YR. YR, we know YR is I1 upon V2. I1 upon V2, right? This was this formula I have already explained, right? This one. Y1 equal to I1 upon V1, Y2 equal to I1 upon V2, and YF equal to I2 upon V1 and I2 upon V2. This is I2 upon V2. So okay, yeah. So this is YF we have going to find. YF. So YF is going to be this one. I2 upon V1 at V2 equal to 0. Right? So I2 value we have found, right? I2 value already we have found. I2 3V2 upon 5. Okay, here we'll find this one. I2 is going to be, again we'll find I2 by current divider rule. Okay, I2 we have to find. I1 we have found. I2. So I2 means current I1 is coming here and dividing into I2 and this part, right? So I2 is going to be I2 is I1 into this resistance upon this resistance plus this resistance, right? This is current divider rule. So this is I1 into 2 upon 1 plus. So this is 2I1 upon 3. 2I1 upon 3, right? So it means YF is going to be I1 upon V1, right? This one is 2I1 upon 3 upon V2. upon V2. V2 value, we know V2 value, we have already found the V2 value. V2 value from here we can get V2 to 3.5. V2 is 3I2 upon this, right? From here a V2 value, right? V2 is going to be 2 by 5 I1, right? Or V1, right? So this is I1, and YF is going to be 2 by 3 I1 upon 3 upon V1, right? And this is going to be 2 by 3 2 by 3 V1 into 3 V1 upon 5. Okay, this is the value of V1, guys. We have got V1 here. V1 value. V1. V1, right? So this is the V1. Okay, we have put the I1 value, guys, not V1, I1 value. I1 value is, we know, I1 value is, I1 value we know, right? I1. 3 V1 upon 5. That's what we have found. So V1 will get cancelled. Very simple. And this is going to be 3 will get cancelled. 2 by 5 MHO. 2 by 5 MHO, right? That is Siemens. Next, YF, YO. YF we have got, not YF. YF we have got now YO. Y output. So this is, we know, I2 upon V2. I2 upon V2, right? I2 upon V2 is going to be I2 is 2 I1 upon 3. We have already found, and V2 value is 5 upon V2. 5 upon V2. So this is going to be 5 upon 3 V2. This is going to be 3 upon 5. Mistake we have done. V2 will get cancelled. Okay, we'll put the value. We'll put the value of I1, right? 2 I1. So this is 2 into I1 value. We have, right? I1 value is this. Right. 2 I2 upon 3. This 2 V2 upon 5, right? 2 V2 upon 5. So if you put it, so this value is going to be, just wait, guys. Okay, so this is 2 I1, I2 upon V2, right? So I1 value will put it, right? So this is going to be like this. 3 V2 upon 5. This is the I2. Okay, we have got I2 upon V2, because I2 value is 3 V2 upon 5. I2 value, this is 3 V2 upon 5. Okay, so now V2 will get cancelled. So 3 by 5 Siemens MHO or ohm inverse. Okay, so this is the answer, guys. So this is how we'll find Y parameters if we have been given questions like this. Okay, so very simple. So just we need to solve these questions. Okay, next is important one, H parameter. Okay, H parameter. H parameters, and they are called hybrid parameter. Okay, hybrid parameters. Okay, so hybrid parameter, this is important one. So here V1 equal to F I1 comma V2 and I2 equal to F I1 comma V2. Okay, so from here again V1 is going to be equal to this one, H1 HI, my apology, HI I1 plus HR V2, and I2 is going to be HF forward HF. Okay, I1 plus H0 V2. Okay, so this is the one. Now I'll write four hybrid parameters. Okay, important one. So first is HI. Therefore you need to note down. Okay, HI is going to be, this is important, V1 upon I1. V1 upon I1 at V2 equal to 0. V1 upon I1. Okay, this is HI. Next is HR. HR is going to be V1 upon V2. Okay, so this is V1 upon I1. Okay, V1 upon I1, this, and this is V2 upon V1 upon V2. Okay, this is at I1 equal to 0. Next is HF. HF is this one, I2 upon I1. I2 upon I1 at V2 equal to 0. Okay, and next is H0. H0 value is I2 upon V2. I2 upon V2 at I1 equal to 0. Okay, I2 upon V2. I2 upon V2. Okay, so these are the hybrid parameters, guys, and if you know this, then you can easily, you just need to know these formula. Okay, you need to note down and memorize these formula. Okay, YR, YF, so YI, YF, YR, YO, similarly HI, HR, HF, HO. Okay, these are very important formula you need to note down. Then if you know this, you can easily solve question. Okay, okay guys, so there is one question I'm going to solve. Okay, regarding hybrid parameter, which is going to clear your all doubt. Okay, regarding hybrid parameter. Okay, so question is, this is the question, guys, have been given. This is 5 by 2 ohm, this is 5 ohm, and this is 35 ohm. Okay, and this is V1, and this is V1, and this is V2. This is V2. Okay, so we need to find the hybrid parameters. Okay, simple one. So now first is HI. HI equal to V1 upon V2. Okay, this V1 upon V2. This one V1 upon I1. HI is V1 upon I1. V1 upon I1 at V2 equal to 0. Right, at V2 equal to 0. So here we'll find first this one. It's important one, guys. Okay, V1 upon I1 means this is R, right? So how we are going to get it there? So this is R. So here we can see V1 upon I1 equal to, this is R1, we can say, right? So R1 means we have to find this resistance, okay, their equivalent resistance. These two are in parallel and this is in series, right? This is 35. Simple one. Okay, so this is going to be that R1, we can just write R1, and that is V1 upon I1, right? And this is R1 means this resistor, that equivalent resistor, and this is going to be this 35 plus these two are in parallel series with 35, right? So 5 by 2 5 by 2 into 5 upon 5 by 2 plus 5. Okay, we solve it. So this value is going to be simple one. So this value is going to be 110 ohm, 110 by 3 ohm. Okay, the simple calculation. This is HI, guys, R1, because this is R1 and R1 means simple V2 equal to 0, right? This V2 is 0, and these are in, you can say these are in the equivalent resistance. We know these two are parallel and series with this one, and this 35 this. Okay, this very simple HI. Next is HR. HR means V1 upon V2. You need to practice it, guys. Then if you practice and solve questions related to H parameter and Y parameter, then you will be able to understand it. Okay. So V1 upon V2 equal to HR equal to V1 upon V2 at I1 equal to 0. Okay. So simple. Again, we know this this one, right? This is the figure we know. So from figure, I'll make figure here as well. Okay. 35. This is 5 by 2 ohm, and this is 35 ohm, and this is V2 and this is V1, right? So HR is going to be this one. So from this we can find here what I'm going to do is I1 is 0, right? Here I1 is 0. Right? I1 is 0, so I will use voltage divider. So so this is going to be the voltage V1. This we need to understand. Okay, V1 upon, that voltage is V1 upon resistance, right? That 330 V1, because here I1 is 0, guys. I1 0 means this resistance is going to be 0, right? So there is no current, right? So this is going to be V1 upon V1 upon, so this is 5, right? So this their current is 0, so it means this resistance is ineffective, right? So here it is going to be this current divider rule or voltage divider rule. So this resistance is there. So V1 upon 5 is going to be equal to V2 upon the effect of these two resistors in this loop, right? So this is 5 plus 5 by 2. These are in series for this. Here, because there is no current here, right? This one. So from here we can get the value of V1, and that is going to be 2V2 upon 3. Okay. Now in this loop we will use we'll use KCL, so KVL. So this is going to be in loop 1, in loop this one V2, this one V2 minus 5 by 2 I2 minus 5 I2 equal to 0, right? So from here we can get the value. So from here V2 value is going to be this one, 15 I2 upon 2. 15 I2 upon 2. Okay, very simple calculation. Now so this implies V1 upon V2 is going to be equal to 2 V2 by 3 upon V2. Okay, so this is going to be V1, this is V1 value 2 V2 by 3, 2 V2 by 3. Right? So this value is going to be 2 V2 will get cancelled. So this value is going to be 2 by 3. Okay, next is this HF. Will find HF. HF means simple, I2 upon I1, right, at V2 equal to 0. V2 equal to 0. So first you can see in first case V2 equal to 0, second I1 equal to 0, and third that V2 equal to 0, I1 equal to 0. V2 I1, V2 I1. Okay. Okay. So here HF I'm going to find. So HF is going to be this one. Again I'll make a figure. Okay. Then it will be more easy. So yes. This is 35 and this is 5 and this is 5 by 2. Okay, so here we'll find I2. This is I1 and this is I2. Okay, so we'll find I2 by current divider rule. I2 means this one. I2 the current is I coming here and dividing it into two parts, right? So I2 is going to be I1 into 5 upon 5 by 2 plus 5, right? This above this, right? So this is going to be I1 into 2 by 3. And similarly, so this implies I1 upon I2, I2 upon I2 upon I1 is going to be equal to 2 by 3, right? And now HF we are going to find. HF means this one, I2 upon V2, I2 upon V2 at I1 equal to 0, right? Again I'll make a figure. This one, this one, this is V1, this is V2, this is V2, right? So this is 35, 5 by 2, this is 5 ohm, right? So H0 we know that is I2 upon V2, right? I2 upon V2. So here we'll use again current divider rule, right? I2 is going to be current divider rule means not current divider rule, my apology. Here I1 0, right? This I1, this is I2. Here I1 is 0, so this resistance is going to be ineffective, right? So I1 is 0, so I2 is going to be this voltage V2, okay? This voltage V2 upon this and upon the resistor, right? Upon this one, this upon this resistor, right? Sum of this resistor 5 plus 5 by 2. Okay, so this is going to be 2 V2 upon 15. Okay, so from here I2 upon I1, I2 upon I1 is going to be equal to 2 by 50. This is MSA, right? Simple thing, because this current is 0. Okay, so there is no current, is 0, so this will be an error, so there is no current, right? So now we'll find that I2, in this loop I2 is going to be this one, total voltage V2 upon these current are in series, right? Because this is not going here, is 0, right? This one. Okay guys, so I have explained H parameters and Y parameters. Okay guys, so I'm going to stop here, and also guys I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exam related to physical science. And also guys, please share my details with your my lecture details with your friends so that they will also be benefited from my lecture. Okay, thank you so much guys. Bye now.